Okay, gang, this is our last lecture before we have our first exam. Urban Heat Island, the role of thermal inertia. Da, 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 da. And if you look in the distance, that's Phoenix, and that's Bank One Ballpark before it was Chase Field, I am pretty sure. Good old days. Okay, so what is Urban Heat Island? The reason we're covering this is it's kind of relevant to Phoenix, so I'm gonna teach you about it. Urban Heat Island is in the city in the late afternoon and into the early evening. The city will be warmer than the surrounding area, definitely warmer than the rural areas and commercial areas. The city heats up, but again, late afternoon and into the early evening and night. Some important factors. The first one is albedo. And we've already covered this, but just to cover it again. The wider the object, the higher the albedo, the higher the reflectivity of the surface. The darker the object, the lower the reflectivity. And the general gist is the whiter the color, the more it reflects, it doesn't get as hot. The darker it is, the more it absorbs, the warmer it gets. If you're trying to cool off a city, you're better off having white things than you are dark things. Moisture and vegetation. We kind of covered this with continentality. If you're near an ocean, you tend to moderate your temperatures. You don't get as hot or cold. Grass and trees are not the same as an ocean, but they do have an impact. They'll help keep things cooler through at least evaporative cooling. So these are two ways in which you could cool things down, is having white things and having vegetation. Some other key terms you need to understand. First one, thermal inertia. This is definitely one to impress the in-laws with. The potential of a material to absorb and store heat. So some things have high thermal inertia. They can store a lot of heat, kind of like a battery. Other things have low thermal inertia. They can't store very much heat. Oasis effect. In the morning and during midday, the city can be cooler than the surrounding rural areas. So it's kind of the opposite of urban heat island. Urban heat island is when the city's hotter during late afternoon and nighttime. Oasis effect is where the city is cooler than the surrounding rural areas in the morning and in midday. And lastly, remote sensing involves the acquisition of Earth's surface characteristics using a remote device. Here's an image taken of Phoenix. Phoenix is right here. Well, I guess Phoenix is huge. But it's showing you the temperature of objects. So it's a thermal image, and it was taken by a satellite. It was taken remotely. Okay, let's learn a little bit about thermal inertia. So oasis effect. Remember, oasis effect is in the morning, midday, the city, where you have a lot of concrete, is going to be cooler than the rural areas where you have a lot of sand. Here's why. Sand has low thermal inertia. This is my diagram, and I apologize, but here's the sunlight coming in, and when it impacts the sand grains, the individual sand grains at the top get really, really hot, but because they only touch at tiny little points, very little of that heat can get conducted deeper down into the sand grains below. So the top ones get super hot, emit a lot of heat, but very little heat gets down below. You've experienced this. If you've ever gone to the beach and you stepped on the sand, you're like, whoa, that is wicked hot. Way hotter than the concrete. But if you wiggle your feet into the sand a little bit deeper down, it's much, much cooler. That's this concept. Sand has low thermal inertia. Concrete, on the other hand, will act like a battery. It'll absorb heat over time and store it deeper down, and therefore it's not going to emit as much heat. Okay, at night, we get urban heat island. In the rural areas, because we only have those little sand grains that absorb the heat, even though they got really, really hot, they're tiny, and so it doesn't take very long for them to emit all their heat, and it's going to get really, really cold. The city, on the other hand, has been storing heat in all that concrete, and it's going to emit a lot of heat. It's just going to pour out into the atmosphere as the concrete re-emits all that energy it's stored through the day. So that's urban heat island. Hope that made sense. Okay, so we were going to do a little experiment, and if we were taking this class in person, I'd do it for you. We could take some sand, represent rural areas. We could take some concrete, which would represent urban areas. And we can let them sit under some heat lamps. And as we let them sit under there long enough, we could take an infrared thermometer, which is we could remotely detect the temperature, remote sensing of these two objects, and you would find that the sand is much hotter than the concrete because the concrete is storing the energy, has higher thermal inertia than the sand, which has lower thermal inertia. And only the individual top grains get super, super hot, but none of that heat gets transferred down below. Maybe impress your friends with that, but it's kind of a lot of work. Here's an example from Mars. You can use remote sensing imagery, these heat maps of Mars, to kind of tell you where bedrock is. So here's a day image, here's a night image. During the day, the ejecta blankets from these craters are white. And the white means they're really hot. And that's because it's a bunch of fine particles like sand that get really, really hot. Can't push that heat deeper down to the surface. But here, the bedrock that's black is storing heat, therefore it's cooler during the day. At night, it's the opposite. The ejecta blanket around the crater emitted all its heat very easily because it's nothing but a bunch of tiny sand grains, low thermal inertia. The bedrock, which had higher thermal inertia and stored heat during the day, emits it at night, and it's warmer. So it has uses. And it's Mars, which is cool. Charlie's Angels. I used to work at a survival school, and the Charlie's Angels came out to my school. I didn't actually get to participate on the trip with them, although I did get to meet all of them. Cameron Diaz intimidated me. But they're also an example of it. So when they went to sleep at night, they went and found a comfortable spot in the sand, which is very common in the Utah desert. But at night, they were like little kittens curled up on bedrock because the bedrock was a lot warmer than the sand. They discovered thermal inertia. Okay, so do me a favor, take a look at this image and see if you can figure out what A is, B is, C is, and D is. A is referring to the grid that you see all over this image. B is this bright yellow object, C is this thing, and D is this blue and green thing here. See if you can figure out what they are. All right, well, if you guess, the grid pattern are the streets, right, which are nice bright yellow. This is Grand Avenue heading off to the northwest. And they're streets, so they're going to be hot. This image is taken at night, so they're going to be hot because they've been storing energy all day. This bright yellow thing is the airport, giant parking lot for planes made out of concrete. It's going to be really, really hot. This is the Sierra Estrella Mountains, southwest of the city, and all the bedrock is bright yellow because it's been storing heat all day. All this red out here is the rural areas. It's not as hot. The coolest area is actually the blue and green are the farms down along the Gila River. So anyway, supposed to be like a fun little activity. And just if urban heat island is going to be important, it's going to be important in Phoenix because our city is huge. Just the city of Phoenix could hold Rome, San Francisco, Paris, and Manhattan. And we still have all this other stuff as well. So we're going to get hit with urban heat island. But what kind of problems do we get from urban heat island? Well, it's just one of those things. It's hot all the time. We live in a very hot climate. It'd be great if we did things to try and keep things cooler. We don't tend to have, light colored parking lots. But that's the kind of general gist. That's why sometimes if you ever leave your friend's house after a great board gaming night, maybe around 11 o'clock, you step outside and you're like, whoa, it's wicked hot. That's because of urban heat island. All right, guys. Here's your things to know list. What is urban heat island? How does albedo, moisture, and vegetation play a role in urban heat island? They need to understand and describe thermal inertia, oasis effect, and remote sensing and their importance to urban heat island. Thanks for listening. Bye.